Use mathematical induction to prove the sum from r equals 1 to n of 2 to the power of r minus 1 is equal to 2 to the n minus 1. Start with our base case. Step 1 is when n is equal to 1. That's the smallest value that n can take. The left-hand side is equal to the sum from r equals 1 up to 1 of 2 to the r minus 1, which is just substituting 1 for r, which is 2 to the 0, which is 1. Our right-hand side is 2 to the power of 1 minus 1, which is 2 minus 1, which is 1. So both the left-hand side and the right-hand side are equal to 1, and that means the base case holds and the statement holds for n equals 1. Step 2 is when n is equal to k. It's our assumption step. We're going to assume that the sum from r equals 1 up to k of 2 to the r minus 1 is indeed equal to 2 to the k minus 1. Having done the assumption, we can move on to step 3, which is our inductive step. It's always worth saying what we want to show, which in this case is that the sum from r equals 1 to k plus 1 of 2 to the r minus 1 is equal to 2 to the k plus 1 minus 1. Start with the left-hand side and split that up into the sum of the first k terms plus the k plus 1th term, which is 2 to the k plus 1 minus 1. We can now make the swap for our assumption, because this is equal to 2 to the k minus 1, and this one is equal to 2 to the power of k when we simplify. We now have two lots of 2 to the power of k minus 1, but using laws of indices, this is 2 to the k plus 1 minus 1, which is exactly what we wanted to show, and that is our right-hand side. So we've completed it for step 3, the inductive step, and we finish, as we always do, we finish our induction with our conclusion, and our conclusion states that since it's true for n equals 1, and if it holds for n equals k, it also holds for n equals k plus 1, by mathematical induction, it must be true for all positive integers.